We are Group 4 of SIH2003 and we are here today to present on two issues affecting soil health, soil salinization and soil acidification. I'm Wang and today I'll be presenting on soil salinization. Soil salinization is a process through which water-soluble salts build in the soil. This is a resource issue because the excess salt can inhibit crop development by decreasing the plant's ability to absorb water. The causes of soil salinization can either be natural or of a result of human activity. The causes of this issue are inappropriate fertilizer application, rapid rate of evaporation, poor drainage or waterlogging, irrigation using salty water, and sea salt infiltration. Soil salinization is detrimental to the environment as well as human society. For one, it can negatively affect agricultural production as well as degrade water quality and increase flood risk. Soil salinization could also negatively impact biodiversity and increase soil erosion. Therefore, saline soil is important to be remediated to ensure soil health. Before a soil can be remediated, the extent of this issue must first be addressed. This can be done through remote sensing and Geographic Information System (GIS). One such technology in the field is hyperspectral remote sensing. This type of remote sensing utilizes narrow and continuous spectral bands to observe the prevalence of halophytes and non-halophytes from orbit. The presence or absence of these plants can be used to distinguish the salinity of the soil in the GIS system through NDVI, brightness index, and salinity index. The remediation of saline soil can be achieved through physical remediation, chemical remediation, and biological remediation. One physical remediation practice to treat saline soil is leaching. This practice essentially amounts to washing the affected soil with water. Chemical remediation of saline soil can be done by applying gypsum and nutrient enrichment. Gypsum is commonly used for its low cost, simpler application and effectiveness over large areas. The other method is by applying nutrients like NPK, magnesium, and hormones like salicylic acid. Saline soil could also be remediated biologically through either phytoremediation or microbial action. Phytoremediation involves using unique plants to capture and remove salts through the soil through bioaccumulation, while microbial action uses certain halophilic soil microorganisms to remediate saline soil. Now I'll pass on the presentation to Nureen.
Hi, I am Nureen and I'll be presenting soil acidification. Soil acidification is a decrease in acid neutralizing capacity or an increase in base neutralizing capacity. Generally, soil acidification occurs as the concentration of hydrogen ions in the soil increases. So what are the causes of soil acidification? First of all, we have climate. Excessive rainfall causes a lot of water passing through the soil rapidly. This results in the leaching soil proles basic elements, for example calcium, magnesium, sodium, and potassium, that actually prevents soil acidity. The next cause is the decomposition of organic matter. The reaction of carbon dioxide and organic acids during the decomposition reaction results in the formation of carbonic acid, which are actually forms of weak acids in the soil. The next cause is crop production. High crop yields cause basic matters to be removed, and this is because crops absorb the lime-like elements as cations for their nutrition. So when these crops are actually harvested and removed from the field, some of the basic materials responsible for counter-reacting acidity is lost. Next, we have application of ammonium fertilizers. Transformation of such sources of nitrogen fertilizers into nitrate releases hydrogen ions to create soil acidity. And the last cause we have here is low buffer capacity from little clay and organic matter. Soil buffering is related to the amount of clay and organic matter present in the soil. The larger the amount, the higher the buffer capacity. Soils with higher buffer capacity, if acidic, have higher lime requirement. Now let's move on to the effects of soil acidification. We have reduction of the reduction of availability of essential plant nutrients, for example, phosphorus, potassium, calcium, and magnesium. The next effect is reduction in root growth. This causes plants to be unable to explore sufficient soil volume to compensate for the reduced chemical availability in the soil. And last effect is that it promotes soil erosion. Soil acidity causes loss of ground cover. And together with the effects of climate change, it accelerates soil erosion and causes lower water quality. Now let's move on to the management practices. First of all, we have applications of agricultural lime. Lime is in fact a solid acid neutralizer, and we call them dolomitic and calcitic limestone. The second practice is to grow deep-rooting perennial species that takes up nitrogen from greater depths in the soil. For example, we have Japanese pagoda, walnut, or pine trees. And the last practice is to have efficient irrigation management, and this is because too much water allows the nutrients in the soil to seep through the soil and carry away important nutrients for the crops. That is all from me. Thank you very much.